This lesson is from Mrs. Cucci's College Now PreCalculus class. We are on lesson 5.3, trig functions of any angle. So go ahead and get that opened up and we'll get started. Okay, so by the end of this lesson, this is a big lesson, there's a lot involved. By the end of this lesson, you should be able to find angles that are coterminal with a given angle and find the complement and the supplement of a given angle. Determine the 6 trig function values for any angle in standard position when the coordinates of a point on the terminal side are given. Find the function values for any angle whose terminal side lies on an axis. Find the function values of an angle whose terminal side makes an angle of 30, 45, or 60 degrees with the x-axis. And use the calculator to find function values and angles. So those are our goals for this lesson. This lesson will span more than one day. 2 to 3. All right, so angles, rotations, and degree measures. An angle is the union of two rays with a common endpoint. That should say point, not joint. Sorry about that. Called the vertex. In trig, we often think of an angle as a rotation. To do so, we have to think of locating a ray along the positive x-axis, having its endpoint at the origin. We're going to call this the initial side, or the initial ray. So what we do is we leave that ray fixed on the x-axis, and we create another ray by making a copy of the initial ray, and we rotate it around. The rotation goes counterclockwise. That would represent a positive rotation. If I were to go counterclockwise, clockwise, that would be a negative rotation. The ray that ends the rotation is what we call the terminal ray, or the terminal side of the angle. And then the angle that's formed is said to be in standard position. So again, if your initial ray lies along that x-axis with its vertex at the origin, we say that that angle is in standard position. Okay, so let's talk about coterminal angles first. If two or more angles have the same terminal ray, the angles are said to be coterminal. They share that terminal ray and the same initial ray. So to find coterminal angles, all we need to do is we add or subtract multiples of 360 degrees. So it's really very simple. What that might look like, well, let's do an example and we'll see what it looks like. All right, so find two positive angles and two negative angles that are coterminal with 51 degrees and negative 7 degrees. Okay. So let's start with 51 degrees. So like we said, the terminal, it shares the same initial and same terminal. So 51 degrees, if I were to draw a rotation diagram for this, the rotation diagram is simply a sketch of the angle itself. Here's my initial ray. Along the x-axis, it's in standard position with its vertex at the origin. And 51, I know, is a little more than halfway between my x and y axes. Okay. So here's 51 degrees. I want to show my direction of rotation and the initial and the terminal. So a coterminal angle could be an infinite number of angles, but we're simply going to stick with one that is by adding the 360 and subtracting the 360. So if I were to do 51 minus 360 degrees, this is going to give me my negative coterminal angle. Okay, it's going to give me negative 309. Now what that would look like on here, again, standard position, except this time, since it's a negative rotation, I'm going this way. I'm going clockwise, and it's going to end at the same terminal ray. Okay, this is negative 309 degrees. Shares the initial, shares the terminal. Okay. All right, so another one would be 51 plus 360 degrees. So it contains a whole extra rotation. So an example of that would be starting at that initial, going around, and then finishing at the terminal. So 51 plus 360 would be 411 degrees. So these are examples of coterminal angles. And of course, there are more coterminal angles, and I can find those by simply adding multiples of 360 degrees. So let's say I wanted 3 extra rotations. I could simply add that multiple to get another coterminal angles. There are an infinite number of coterminal angles. Okay, so the second one was -7 degrees. So now I don't need to draw the rotation diagram. I can simply do the addition and subtraction. And find myself a few coterminal angles. Okay? All right. That's not bad. All right, so now we're going to find the complement and the supplement of 71.46 degrees. Now, if you remember from way back when, complement, and there was kind of a funny way to remember this. Okay, so if we go back way back when to, like, gosh, elementary school maybe? No, not that long ago. Junior high. So if we're talking about complement or complementary angles, those are angles that add up to 90 degrees. And we also are talking about supplementary. So I don't remember who the heck taught me this so long ago. One of my teachers taught me the trick on how to remember this. Complement goes with 90. So from the C you make the 9D. Supplement, you make the 8 from the S. And there's your 8, so 180. Okay, so that's how I was always able to remember it as a kid. Why are they? Okay, so we're finding the complement of 71.46 degrees. Okay, so again, complement means what is the other angle that when added to this angle would make it 90 degrees. So pretty simple. All we have to do here is take 90 degrees and subtract from it the angle that we're given, and we're able to find the complement. Now, supplement's done similarly, except instead of 90, we're using 180. And we take the subtraction, and we get 108.54 degrees. So the complement of 71.46 degrees is 18.54 degrees, and the supplement is 108.54. So that should be just a quick, easy reminder to something you guys already knew. Okay, so trig functions of angles or rotations. So let's suppose that you have a point x5, and it's any point other than the vertex on the terminal side of some given angle theta in standard position. Okay, and r is the radius, or the distance from the origin to that point. Then the trig functions are defined, I'm missing an E, as such. Sine is your y-coordinate divided by your radius. Cosine is your x-coordinate divided by your radius. And tangent is your y-coordinate divided by your x-coordinate. Okay, similarly, we have our reciprocal trig functions, cosecant, which is just going to be the reciprocal of sine. Radius divided by your y-coordinate, secant, radius divided by your x-coordinate, and cotangent, x-coordinate divided by your y-coordinate. Pardon me. All right, so we're going to find the 6 trig function values for any angle, for each angle shown. Okay, so that's on our next page. All right, so we've got my rotation here. Okay. And what I should have in here that I seem to be missing is I should have my direction of rotation, which is right here. Okay. My hand, go away. Come on. Follow me, little hand. Okay, there's my direction of rotation. Okay. So the first thing we need to do is we need to determine the radius or the distance from the origin to the point that we're dealing with. Okay, so my radius, right? We need to determine what that is. So what we know is, since this is the point -4 and -3, I've gone over -4 and I've gone down -3. So this is a 3, 4, and real quick, because we know our common Pythagorean triples, this is going to be our 5. Okay, so what we're going to do, since I know it's a 3, 4, 5 triangle, is we're going to determine sine, cosine, tangent, cosecant, secant, and cotangent for this 3, 4, 5 triangle. Keep in mind that it's in the terminal ray terminates in the third quadrant, and since we know all students take calculus, we can determine if our trig functions are going to be positive or negative. All right, so what I'm going to do, just to make this a little bit easier to see, is I'm going to transfer this to another paper. I'm going to take a look at the right triangle, just oriented a little bit differently. Okay. Okay, so all I did was I reoriented my triangle, and notice I wrote them using positive values. The reason I did that is because distances are not negative. Okay, so I made them positive, and then we'll determine the sign based on the quadrant. Now keep in mind, this triangle was created with the x-axis in this quadrant here. We're in this third quadrant. That's our all students take calculus. Okay, so we're going to look for sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now it's important that we make sure we have the right angle here. The angle created is the one that's created from the origin, from the vertex of the angle. So we need to figure out, make sure that we have the right one here. So I'm going to go back and take a peek. Here it is right here. Okay, so it is opposite my 3. Okay, so it's this angle right here. Okay, so sine we know is the ratio of opposite over hypotenuse. So opposite over hypotenuse, or 3/5. And we need to check the quadrant. And since we know it's in quadrant 1, 2, 3, the only trig function that's positive here is tangent and cotangent. So sine needs to be -3/5. Cosine is adjacent over hypotenuse. So that's your 4/5. And again, third quadrant, cosine is negative. Tangent is opposite over adjacent. So opposite, adjacent. And because we are in the third quadrant, tangent is positive. All right, now, we talked about reciprocal trig functions, and we know that we simply take the reciprocal of what is here. Okay? We could use hypotenuse over opposite, hypotenuse over adjacent, and redo this if we wanted to, but since we know they're simply reciprocals, we can go ahead and take the reciprocal of each of these. Okay? And there you have it. Okay, let's try another one. So we've got 1, 1. We need to find my radius. So let's go ahead and do this on the other paper. We know the legs are 1 and 1. We do not know the hypotenuse. Okay. So to find that, we have to use Pythagorean theorem. I know because we have done these triangles what this is, and my trig students, my pre-calc students should know automatically what this is because we have memorized our 2 special right triangles. But for those of you that don't remember, 1 squared plus 1 squared equals b squared, or c squared, I apologize. Okay, 1 squared plus 1 squared is 2. Take the square root, we get c equals the square root of 2. 1, 1 square root of 2. So that should remind many of you that this is going to be a 45, 45, 90 triangle. Okay? So, here's my angle theta. Alright. So sine is opposite over hypotenuse. Now, that gives us 1 over the square root of 2. Remember, we're in the 4th quadrant. Okay? 1 over the square root of 2. We don't like this. This is ugly. So we do want to rationalize it. And we can rationalize it simply by multiplying by the conjugate, which is going to give us square root of 2, 1 times square root of 2, over square root of 2 times square root of 2, which is the square root of 4, or 2. Last step is to decide, okay, I'm in the fourth quadrant. What does that mean for sine? It means sine is negative. Cosine, adjacent over hypotenuse, 1 over the square root of 2. Don't need to do the work. I already know what it is, square root of 2 over 2. Okay, and because I'm in the fourth quadrant, all students take calculus, cosine is positive. Tangent is going to be opposite over adjacent. Opposite over adjacent is 1 over 1. And since we are in the fourth quadrant, it is negative. So let's deal with those reciprocals. Cosecant theta. Now generally, I don't want to go take the reciprocal from here. Reason being is now I would have to rationalize again. So take it from where we started, okay? 1 over the square root of 2, so this just becomes square root of 2. And of course, it's negative because of the fourth quadrant. Secant is going to be the same thing except positive. And tangent, the reciprocal of 1 is 1, or negative 1, okay? Let's try one more of these. All right, so I've got negative 1 square root of 3. And again, this is some bells should be ringing for some of you. Okay. Okay, so I need to find my hypotenuse. So again, we're using Pythagorean theorem. 1 squared is 1, 3 squared is 3, which is going to give us 4. Take the square root and we get 2. So 1, 2 squared of 3. Bells should be ringing. 30, 60, 90. Okay, those are the angle measures here. All right, so sine, cosine, tangent, cosecant, secant, cotangent. All right, sine again, opposite over hypotenuse, square root of 3 over 2. Let's go back and double check. What quadrant will we in? Second quadrant. Okay, sine is positive. Cosine, adjacent over hypotenuse, 1/2. Second quadrant, cosine is negative. Tangent, opposite over adjacent. Opposite over adjacent is going to be square root of 3 over 1, or just square root of 3, and that's negative. I'm going to go ahead and take these reciprocals. 2 over the square root of 3, and we know we're going to have to adjust that. Multiply by the square root of 3 over the square root of 3. 2 square roots of 3 over 3. Negative 2 over 1, or just negative 2. And then negative 1 over the square root of 3. Of course, we're going to have to rationalize. So negative square root of 3 over 3. Okay, so that's about all we have time for today. So we're going to pick up here for the next lesson. So please come prepared with any questions you might have, and I will see you guys tomorrow. Thanks.